Hey there, ladies and gentlemen. Section 5.5, Empirical Formula. This is the direct continuation from yesterday's lesson in lab. What we are going to do today is take the percent composition of a molecule and turn it into an empirical formula. Now, the empirical formula isn't even the final product. We're going to do two things today. Once we find the empirical formula, which I call the fake formula, it's totally fake. It's just the simplest ratio of all the elements. We're going to eventually convert it into the real one, and it'll be later at the end of this video. So to go from the percent composition to empirical formula requires a few steps. Okay? So here are all the steps typed out. May not be the best way to learn this, but here we go. You have to start with the percent composition, and you can just instantly write that as a gram. You can assume that you have 100 grams of a substance, so the percent is the grams. Then from grams, you can determine the number of moles of each element. That's really easy. We've been doing that all chapter. Then you have to find the ratio between them, or the relationship between them, and you do that by dividing all of the moles by the smallest number. So you reduce everything down to a ratio. Then, if you have a decimal place, which you will most of the time, you then have to multiply them all by a number. 2, 3, 4, 5. Has to be one of those to get a whole number. So read that over a couple of times if you want. But here's a cheesy little rhyme that was told to me. It completely works, just don't laugh. It's percent to mass, mass to mole, divide by small, multiply till whole. Okay? If you come to class tomorrow with a rap or something with that, awesome. Don't spend too much time on that though. So here we go, moving on. Let's just do an example. You'll see these 4 steps in order. I'll try to keep this 4 steps at the top of the page. A compound consists of 72 magnesium, 27 nitrogen. What is the empirical formula? Well, first thing we need to do is convert the percent to mass. So magnesium up there, nitrogen. Well, if you have 72.2%, you have 72.2 grams, real hard. And then 27.8 grams. Again, you assume you have 100 grams of it, so the percent is the mass. Then you convert it into moles. So times 1 mole. Magnesium, it should be 24.3. Nitrogen is 1 mole over 14.0. That we have a different number of moles. The third step is to find the ratio. We always want something to be a 1. So we're going to divide by the smallest number. So I'm going to divide by 1.98. Divide by 1.98. That's going to give me 1. And this is going to be 1.5. So you can't actually have half of like 1.5 in a formula. You have to have whole numbers. So you need to multiply these numbers by something that makes them whole. And you're going to start with 2 and then 3 and then 4 and then 5. One of those numbers has to work. So I'm just going to multiply both of these things by 2, and you're going to see that that gives me a ratio of 3 to 2. Well, those are the subscripts in our formula. So the actual answer, the actual empirical formula is Mg3 N2. We're done. Percent to mass, mass to moles, divide by small, multiply till whole. It's cheesy, simple, works every time. So once we know the empirical formula, which is the fake formula, we have to somehow get the real formula, which is called the molecular formula. So in this little box, I have some very simple examples. You're going to notice that if the empirical formula is HO and the molecular formula is H2O2, we basically just multiply that by 2. If the empirical formula is CH and the real one is C2H2, again, we just multiply it by 2. Or maybe we multiply it by 6. Or maybe we don't multiply it by anything. Maybe the empirical formula is the molecular formula. Well, how do we know the relationship between the empirical and the molecular? Well, that's what we're going to quickly chat about now. The relationship between them is some multiple based off of their molar masses. And let me show you how simple that is. If I'm telling you the empirical formula, or the fake formula, is ClCH2, we need to find the molecular formula. Well, we have to compare its molar masses. So ClCH2 is 19.5 grams per mole. The question tells us the real one weighs 98.96 grams per mole. So they have to be some whole number multiple ratio between each other. So if all you have to do is take 98.96 divided by 19.5 times 5. So this is going to be Cl5 C5 H10. That's the molecular formula. If the molar masses are 5 times different, then the formulas are 5 times different. Let's try it again. Our empirical formula is CH. It's going to have a mass of 13.0. Our molecular formula we got to find. The question tells us it has a mass of 104. So what do you got to do to 13 to get 104? Well, divide them. You're going to have to multiply this by 8. So we're going to have to multiply that formula by 8 and get C8H8. So that is the answer. That's the molecular formula. So in the last 2 days we went from percents to the empirical formula. Now we can find the molecular formula, the actual real formula. So hopefully you're comfortable with this, because this is where things start to get twisty. What happens if the question doesn't give you molar mass of the real thing? The question can be a jerk and hide the molar mass. And we have actually calculated the molar mass in 3 different ways over the past 5 or 6 classes. You just may not have realized that. So let me quickly show you the 3 different ways to get molar mass. So let's first realize that molar mass has 2 numbers involved. It has moles and mass. It has moles and grams. So you need grams on top and moles on the bottom. So the simplest way for me to hide molar mass is just to give you 2 numbers, grams and moles. So the molar mass of this fake compound would be grams over moles, which would be 1.775 grams divided by 0.0250 moles. That is the molar mass in grams per mole. Another way for me to give you molar mass is to hide it in the form of density and STP. This seems very complicated, but let me quickly show you how it's not. All year we have been practicing to calculate and to convert units. Density is mass over volume, and it's 1.43 grams per liter. We know that STP is liters and moles. Well, we have to arrange that so it cancels off to give us grams over moles. So I've always said, and you have always been right, if you want to get rid of liters, they have to be on opposite sides in the next step. Well, we don't want to get rid of grams. We want grams on the top. But we do want to get rid of liters. So if we say 22.4 liters and put 1 mole on the bottom, you're going to notice that our liters cancel off, and what we're left with is grams per mole, which is molar mass. So the density times the STP actually gives us molar mass. And the last way that I can hide it is with 3 numbers: a mass, a volume, and STP. Well, guess what? Mass and volume is density. So this really is the same thing as example number 2. So I'm going to start with my mass on top and my volume on the bottom. Cancel off liters, putting 22.4 on top over 1 mole. And guess what? There it is, grams per mole. Liters cancel off, and I'm left with grams per mole. So I have 3 different ways to hide molar mass, but technically it's only 2 ways to hide molar mass: density and STP. Trust me, we will be practicing this tomorrow, and you're going to be doing a bunch of this stuff in groups. It's going to work out well. See you then.